Our first presenter will be Dr. Jim Sutherland. Jim is familiar to many of us who work on research in hydrology in the Adirondacks and specifically Lake George. Without his scientific research, many of our water resources would be in a much worse condition than they are. And Jim will talk about one of our research projects here at the LGA. Jim?
Right, yeah. Thank you, Chris, and thank you to all of you who are participating in the room and remotely. I would be remiss if I did not mention many thanks to Chris, to Eric, to the former Fund for Lake George, now the LGA, for starting this initiative many, many years ago, and the great success that salt reduction has had in the Lake George Basin since that time. The project I would like to talk to you today regarding is our road salt monitoring effort that's tied in with the New York State Department of Transportation initiative in the Lake George Basin. What you see on the left is a graph. The y-axis is concentration of sodium and chloride in Lake George on an annual basis. The x-axis extends from 1980 until 2009, when the famous 30-year report on water quality in Lake George was released. And one of the startling things that came out in that report was the fact that sodium and chloride in Lake George on an annual average basis had increased threefold since 1980. And we knew from our experience with monitoring tributaries around the Lake George Basin that road salt was a likely culprit for those increases in sodium and chloride. And since that time, when the report was released in 2014, there was another study that came out, Mark Swinton et al., that found that there is a direct correlation between the surface area of roads and highways in different watersheds in the basin and the chloride concentration found in streams draining those watersheds and entering Lake George. Subsequently, a group of us, including Chris, Steve Norton, associate professor and a professor at the University of Maine, we did a study on Finkel Brook in 2016. We looked at data on Finkel Brook extending back to 1970 when Wolfgang Fuß from the New York State Department of Health did a very important study around the Lake George Basin. And what we found as a result of looking at these data is that if you take a watershed, let's say a pristine watershed, pristine soil, you start adding road salt to the road surfaces, the sodium and the chloride enter the soil surrounding the highway, and you have a process whereby sodium binds to the soil and it releases the three cations that you see here on the first bullet, calcium, magnesium, and potassium, releases those into the groundwater, subsequently into the streams. They enter Lake George, and as we know here in Lake George, particularly calcium and magnesium can be problematic in high concentrations because they foster the growth of nuisance aquatic species such as zebra mussels and Asian clams. So the concentrations of cations that we saw in this study follow an ion exchange model whereby you have high concentrations of these cations entering the stormwater runoff during high flows. And as we all know, chloride is relatively conservative in the soil and is not bound by normally any compounds in the soil. So a little bit about the New York State DOT Road Salt Reduction Pilot Program at Route 9N. There is a sister study that was started up in the Whiteface Mountain area on Route 73. But the study we're talking about today, if you see the aerial photograph on the right side of the screen, the test segment of Route 9N runs from the village of Lake George up to Padanaram Road, which is at the base of Tongue Mountain. It's approximately a 7-mile stretch. We wanted to evaluate the road salt reduction program based on the response of tributaries that we would find along this road segment. However, the important factor here is that we needed to find tributaries that had no other influence besides the road that crossed that section of the watershed. And Chris and I, when we formed this study back in 2018, we decided that we would locate 2 test watersheds and 2 control watersheds, which would be outside the Route 9N area and not subject to the road salt reduction program. The goal of our effort then was to evaluate the effects of reduced road salt on the chemistry of tributaries that flow into Lake George. We wanted to see what that impact would be and how effective that 10% reduction in road salt would be in changing the chemistry of those tributaries that flow into Lake George. One of the goals was to set up a monitoring program that would collect enough data to be able to document and evaluate the changes in chemistry if they did occur. And we also, at the same time, wanted to make this a program that would become long-term if necessary, because we had no idea when we initiated this program, how long it would take to evaluate this entire process. So what you see here are the 2 test tributaries that we were able to locate at the extreme end, almost the extreme end of the 17-mile segment of Route 9N. These tributaries are numbered according to the DEC system of classification for streams flowing into Lake George. But the important point to see here is that both of these sub-watersheds or watersheds are fairly small. They do have highway segments that run through them. The important point here, as I mentioned earlier, there is no other upland influence on these tributaries other than the segment of highway that crosses that watershed boundary. And therein is where Chris and I had a great deal of trouble, because we started at the village and worked our way north over a several-day period in a car with maps. And these were, believe it or not, the first 2 tributaries that we were able to locate where there was no other upland influence, just the road segment itself. These are the 2 control tributaries. One is on Route 9L on the east side of Lake George down near the south end, and the other one is Tributary 41, also known as English Brook, which is the 6th largest watershed in the Lake George Basin. And we looked at a segment where the brook comes down and runs adjacent to Route 9 at the crest of the watershed, and then runs for about 1.2 miles before it crosses underneath I-87. So the test and control tributaries were both sampled above and below the area of highway influence, and we sampled at about 2-week intervals. We collected water samples for the analysis of anions and cations. And we also, at every visit, collected flow data and the various field measurements shown here: dissolved oxygen, specific conductance, total dissolved solids, and pH. All of the lower sites at these 4 stations were instrumented. We had an on-set HOBO conductivity temperature data logger. We had an in-situ rugged Troll 200 water level logger, and an accompanying in-situ Troll barometric pressure logger, which compensates for barometric pressure and corrects the water level at the site. The photograph on the left shows the HOBO temperature conductivity logger, and the photo on the right shows the conductivity temperature logger enclosure. Another piece of equipment, as I mentioned just previously, was the in-situ rugged Troll 200 level logger, which is shown on the photo on the left. The barotroll is shown on the right. And this is a wireless troll which is taken out in the field by people who go out and sample. And it's used to download the data on site using a Bluetooth connection to a cell phone. so that the instrumentation does not actually have to be removed from the field location. The photo on the right shows the hobo conductivity logger installed in the segment of English Brook where we do the lower site monitoring. The photo on the right shows the troll data logger installed along the stream channel measuring water level. All data loggers at these lower sites are programmed to record data at 5-minute synchronized to clock intervals. They're downloaded at approximately bi-weekly intervals. The data are stored in individual master Excel files for each of the lower sites. And in situ, as I mentioned previously, with the barrel merge, has a program that corrects the level measured in the stream for changes in barometric pressure. So there are some key things that we need to know about this program that we established. Accurate gauging is critically important, and it has to occur under all types of conditions at all times of the year. This is the lower site on English Brook, as you can see, very close to Route 9 as it heads north towards Warrensburg. What you're seeing on the left here or on the right is a portion of the Excel master file that is used to record the date of the field trip, the time, the gauged flow, and then the reading that comes from the Troll 200 that is in the stream channel. And what you do is you pair the troll readings and the gauged flow in the stream to develop a rating curve. And that rating curve, as you see on the left, is used to take the 5-minute levels from the troll and calculate flow in the stream so that we end up with 5-minute flow values. I haven't shown it here, but you do the same thing with the hobo specific conductance data logger. You pair the conductance readings from the hobo with the chloride levels that are measured at the laboratory. In this case, we use the Darren Freshwater Institute laboratory in Bolton Landing. And on the right there, you see the curve that describes, for English Brook, the relationship between the hobo-specific conductance reading and the chloride that's measured by DFWI. All right, the table that you're looking at here is a master table. On the far right, or far left, I'm sorry, the date and time at 5-minute intervals. The next column in is the water level, the flow per 5-minute interval, the specific conductance reading, the amount of chloride based on that reading through a calculation, and then the pounds of chloride in the stream per 5-minute interval. The orange bar near the bottom of the table is a 24-hour summary. And what you see over on the far right is the daily chloride load in pounds from that stream at that particular location and the average flow that occurred at that site on the stream channel during that 24-hour period. We then have another series of tables in this same program that do lookup values and record the daily chloride and the daily flow for each day. As you can see here, currently in 2021, we have the data summarized through September 27th of this year. And this is a graph that just shows a comparison. Now, Chris and I, when we first started this study, based on my experience at Finkel Brook in Bolton Landing, which I've studied since 1992, I thought that each of these streams would show a nice relationship between flow and chloride. But that wasn't the case. We did see this at English Brook, but at these smaller tributaries up in Northwest Bay, we did not see this relationship between flow and chloride. It therefore became essential for us to buy the data loggers which record level, which we convert to flow, because we needed that information in order to have enough data to make a serious evaluation. What you're seeing here, in May of that year, when we set up the in situ level loggers, and you're seeing the summary, the blue bars on the left graph summarize the chloride loading for 2020, beginning in May and ending in December. And the red bars summarize the chloride loading for the same period of time at all three stations. The graph on the right merely shows the difference in total flow that occurred at these stations, both in 2020 and 2021. Just to go back a bit, the goal was to evaluate the effects of altered road salt reduction. Our objective was to set up a stream monitoring program that would conduct enough sampling that could evaluate whether the reduced road salt application policy was working. Hopefully, as a result of all this data collection, we would be able to make an evaluation and move forward with recommendations which either said, yes, it's working, no, it's not working. And as this program began years ago, began discussions with NYSDOT. This was considered a partnership between then the Fund for Lake George and the New York State Department of Transportation. And DOT's obligation was to implement the road salt reduction program, and the fund would implement the monitoring. So what we had that we needed more than anything at this point, after several years of monitoring, was the road salt data that, in terms of the amounts applied in these areas that we've been studying for several years. We submitted a series of FOIL requests to request the data from DOT for a 3-year period. We finally received the data in April of 2021, this year. We then realized that it was not possible to interpret the data because of the formatting of the data, and it was different from the vehicle location system that Chris and Bria and others have been using for the system in Lake George that was implemented by the Fund for Lake George several years back. So eventually a telephone conversation with someone at DOT straightened out the formatting issues, and we just now, as a matter of several weeks ago, have been able to go back and start our evaluation of this process. Just a couple of takeaways, and again, I would have been remiss if I hadn't mentioned the effort on the Fund for Lake George years ago to start this whole initiative. In doing so, what they did was develop a model of protection consisting of partnership, innovation, and investment guided by science. We now know that implemented best management practices begin with training and measuring. And we know that also that road salt reduction can be achieved without sacrificing public safety. We just don't know yet whether, in fact, we're seeing a 10% reduction in these tributaries, because we just haven't gotten to a point where we can look closely enough at the data, but that should come in the next couple of months, and certainly we'll be ready to report that when it does occur. And I just want to thank you for your time and effort, and if anyone has any questions, I'd be glad to try and answer them.
Thank you, Jim. Is there any questions for Jim?
Yes?
I was just curious, winter severity, was winter severity factored into any of these at all? When you do your final findings as well?
That's something that I actually, Bria and I talked about that the other day, trying to go back and look at each of these various winters and determining when the precipitation occurred, how much precipitation there was, and what form it occurred in, so that we can look in terms of, maybe correlating that with the amount of salt that was applied and what the resulting effects were of that. So we will be looking at that. It's just that we haven't gotten to that point yet. And as we all know, localized weather, it's very hard to know what the localized weather is, for instance, on this particular segment of Route 9N, because it can change drastically from the south end to the north end, just in that 17-mile stretch. Yes?
Hello. My question is more research going on related to how to mitigate the salts that are already in the lake. Do you know of anything being done to help? Because otherwise we got to wait for flush rates to get the salt out. I mean, the work you guys are doing is great to reduce what's going in, but
Right.
Lake George takes approximately 8 years to flush out.
Right.
And so You know, we've got 30-plus years.
Yeah, I'm not familiar with any work that's actually been taken on to try and figure out if this can be mitigated in lake. As you said, it's a matter of
Time.
the lake flushing out, yeah, over that 7 or 8 year period.
Thank you.
Okay, Jim, thank you.
Thank you.